Okay, so today we are going to talk about Aufbau's principle. So what does this principle states? It states that the orbitals of elements must be filled according to their successive energy levels. Now this is just a statement. It doesn't mean nobody can infer a lot of information from this particular statement. So we're going to dive deep into this particular topic, which is Aufbau's principle. This was just the heading to let you guys know that what we are actually going to study. Okay, so as you guys know that atoms have electrons, which is very basic, right? So let's suppose I want to write the electronic configuration of helium, or maybe carbon, or maybe both. Okay, so we're going to write the electronic configuration of carbon and helium. Okay, first carbon, so I'm writing, so it is 1s2, okay, 2s2 and 2p2. okay, it has four valence electrons, okay, in its valence shell. The valence shell of carbon is the second shell. Okay, now I'm going to write helium. Okay, it is 1s2, 2s2, 2p6. okay, it has 8 valence electrons. Now how did I write this? I must have been following a particular sequence of writing the orbitals and filling them accordingly, right? So there is a rule which I wrote earlier, is that you have to fill or write the particular configuration in accordance to the increasing order of their energy levels. Okay, now how is the energy levels determined? It is determined by the N plus L rule. Okay, now N is the principal quantum number, or vaguely you guys can say that this N represents the orbit number. Okay, and L is the azimuthal quantum number, which represents the value of subshells. Okay, for example, the value of S is 0. Okay, the value of P is 1. The value of a D orbital is 2. We have read SPD. Now F has a value of 3. Okay, so now I'm going to go ahead. For example, you guys must have noticed that in the fourth period, if I'm not wrong, in the fourth period, you have, one second, here n is equal to 4. Okay, I'm just drawing a rough diagram of the modern periodic table. Okay, we have calcium here, and we have 10 D block elements. Okay, 10 elements. Okay, and then we have 6 P block elements of the fourth period in the modern periodic table. Okay, now what is the electronic configuration of potassium or calcium? It is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, right? This is for calcium, and if we remove one electron, then this becomes the electronic configuration of potassium. But just right to calcium, there is an element which is scandium. Okay, and the electronic configuration of scandium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Okay, and now pay attention to this one. It is 3d1. Now this is some magic going on here. This is very arbitrary. It must have been looking very arbitrary. Why did the 3D subshell come after the fourth one, 4s? It is because of the n plus L rule in accordance to the Aufbau's principle. So if you want to compare the energy levels of both these, it is n for 4s is 4, s is 0, which equals 4. For the 3D subshell, the value of n is 3, as it is written here. It is pretty obvious. And for D is 2, okay, 3 plus 2, which equals to 5. So 5 is a larger number than 4, which is why the 3D subshell is filled after 4s and all these subshells are filled, because it has a larger value. Okay, if you want to calculate the n plus L value of 3p subshell, it will be 3 plus 1, sorry 1, yeah, 3 plus 1, okay, which equals to 4, because the value of L for p orbital is 1. For s it is 0, for d it is 2, and for f, as I've said, the value of L is 4. Okay, oh god, my hands are getting spoiled. Yeah, so now the question arises is that why 3p came before 4s? Because both the values of both these subshells are 4. Now in case of this kind of situations, a conflict arises, so we go we decide on the basis of the value of n. Okay, now the n plus L value of both these subshells is 4, and 3 is a smaller number than 4. Okay, in case of a conflict, we then decide by the value of n, the orbit number, okay, the shell number. Okay, it is 3, which is lower than 4. Okay, so it was filled before 4s. Now the value of 3s, n plus L, it is 3 plus 0. Oh god, 3 plus 0, it is 3, right? So 3s was filled before 3p. Okay. This is how our modern periodic table has been designed. It is designed on the basis of increasing energy levels of different subshells. Okay, so the atoms are in the increasing order of atomic numbers also. Okay, now let's suppose I want to write the electronic configuration of, what should I choose? We have helium, neon, argon, and we have krypton in fourth shell. Okay, it is in fourth shell, fourth period, you guys can say fourth period. Okay, I want to write the electronic configuration of krypton. Okay, so I'm going to write it. So it will be 1s2, then 2s2, then 2p6, then 3s2, then 3p6, oh god, yeah, 3p6, now 4s2, 3d10, as I explained in the previous part of this video just before, 3d, and now 4p6. Okay, 4p6 because it is a 18th element of the fourth shell. Okay, yeah, 18th. So how are you guys going to remember this series? It is pretty simple. Let me show you. Okay, so it is filled according to this you guys can say chart, okay, or maybe table. So it is filled like this: 1s, 2s, just bear with me, okay, because I know it seems complicated, but 1s, 2s, 4s, 3s, 4s, 5s, 6s, 7s, and I've got no space left. I'm going to write 8s. I think I'll erase this one, and I'm going to write it again: 1s, 2s, 3s, 4s, 5s, 6s, 7s, 8s. Okay, pretty good. Now 2p, 3p, 4p, 5p, 6p, 7p. Okay, now 3d, 4d, 5d, 6d, and you have got 4f and 5f finally. Okay, now how is it filled? It is filled like this. Okay, see, it goes like this, from 1s, again backwards, then 2s, then again this arrow goes backwards, in between 2s and 3s, goes again to hit 2p, then 3s, goes again backwards and will hit now 3p, and now 4s, and will again go backwards and will hit 3d, 4p, 5s. This is the sequence. Okay, so that is all about Aufbau's principle. And for just a little bit more clarification, let's compare some subshells. Okay, let's compare 4s and 3d. Okay, and let's compare 4s and 4p. Yeah, so the n value, okay, I'm going to write it here, n and l. Okay, so the value of n in 4s is 4. The value of l as a methyl quantum number in 4s is 0. Okay, which equals 4. The value of n and l in 3d is 3. The value of d is 2, equals 5. Okay, so in the periodic table you guys see that 3d elements, basically the 10 3d elements, because d orbital can accommodate 10 elements, which is why we have 10 elements in the 3d series of the modern periodic table. Okay, which starts from scandium, okay, which has 1 electron in the 3d subshell. 2, it goes to, I think, zinc. Yeah, it is zinc, which has 10 electrons in the 3d subshell. Okay, now 4s and 4p. Okay, again the n plus l value of 4s is 4, and for 4p is n plus l, 4 plus 1, 5. Okay, now 3d also has 5 and 4p also has 5, but as stated earlier, in case of conflict, if situation arises in like this, in this case, we decide according to the lesser value of n, which is principal quantum number, the orbit number or the shell number. Okay, now 3 is a smaller number than 4. Okay, the n value. Okay, so 3d is filled before 4p. Okay, and also I'll repeat it one more time, that our modern periodic table which we study is designed accordingly to this rule of Aufbau's principle. Okay, so that is all. And also I'll be posting 2 more videos in succession to Aufbau's principle. It will be one I'll be posting about Hund's rule of maximum multiplicity, and one will be Pauli's exclusion principle. Okay, exclusion principle. Now these 2 rules or laws, whatever you want to call them, these 2 will help you while drawing the electronic configurations. Now what I mean about drawing is this. Okay, for example, we wrote the electronic configuration of carbon, which was 1s2, 2s2, 2p2. Okay, now I'm going to draw this. Okay, so for 1s there is a single orbital, for 2s, okay, there's a single orbital, and for 2p there are 3 orbitals. Okay, 1 2 3, and it is filled like this. So why didn't I couple these 2 electrons? Well, those such queries will be answered in the coming videos, which will be of Hund's rule of maximum multiplicity and Pauli's exclusion principle. Okay, that's it guys. Thank you so much. Thank you for watching. And also, if you're finding these videos useful in your day-to-day academic life, then please subscribe. Okay, thank you.